Welcome to our channel. In this video, we are going to discuss the concept of stepper motor interfacing with 8086. So first of all, we will see what is the difference between a DC motor and stepper motor. DC motor means which rotates in a continuous manner, very fastly it will rotate, means like our water motors. Whereas for stepper motor rotates in a discrete manner, means step by step it is going to rotate. For example, if you see this wall clock, here if you observe here, this seconds hand is moving in a step by step discrete manner. So if the motor rotates in a step by step, then that is the operation of the stepper motor. Okay. So in this video, we are going to cover the assembly language program for 4-phase stepper motor. For clockwise 5 rotations, for anti-clockwise 5 rotations. We need to write the assembly language program. So here in the question itself, they have given the 4 phase. So we need to consider the 4 windings: winding A, winding B, winding C, and winding D. And here they mention that clockwise and anti-clockwise. So clockwise we will take, here for the clockwise we will use the rotate left operation. Means in the step 1 I have taken the sequence 10000. Okay, rotate left means bits are moving towards the left. So here in this second step, the coil, that is the winding B, is turn on. Okay, in the next step the winding C is going to turn on. In the next step winding B, in next step winding A is going to turn on. If you take the anti-clockwise, here we are using the rotate right operation. Means we need to move the bits towards the right side. So in the first clock cycle, I have taken the same sequence, that is 10000. In the second step, it is moving towards right. 1 means here winding B is on, winding C on, winding D on, again winding A. Means for clockwise we need to prefer the ROL, and for anti-clockwise we need to prefer the ROR. And now we will discuss one important point, that is how to calculate the step angle. Okay, in order to complete one rotation, stepper motor will take 200 steps. Okay, stepper motor will take 200 steps to cover the one rotation. One rotation means entire 360 degrees. Okay, complete 360 degrees rotation. For one rotation it will take the 200 steps. Here they have asked for 5 rotations. Okay, they have asked for the 5 rotations, but for one rotation it is taking 200 steps now. Therefore for 5 rotations, 5 into 200 steps means here we are getting the 1000 steps to complete the entire operation. This 1000 we should move to the CX. Okay, these 1000 steps we need to move into the CX. Now we will go to the assembly language program, then you can understand. Now we will start writing the assembly language program with the first instruction, assume CS code. That is, we are telling to the 8086 assume CS as code, that is code segment. And next we will start the program from here. Start colon move AL comma ATH, and whatever the data we are moving the 80 into the AL, we need to move this 80 AL into the CWR. Okay, out CWR comma AL means here CWR means control word register. What is the necessity of control word register here? Means if you take here, for suppose 8086, we are interfacing stepper motor to the 8086. So can we directly interface stepper motor to 8086? No. Why? Because we can't interface directly stepper motor to 8086. Why? Because here we are not having any IO pins. So there is no IO pins in 8086. So how can we directly interface the stepper motor to 8086? So it is not possible. Then what we need to do means we need to place one peripheral interface, that is calling it as 8255. We need to place the 8255 in between the stepper motor and 8086. We need to give the input to the 8255 and 8255 output is connected as the input to the 8086. So here why we are using 8255 means it is calling it as programmable peripheral interface. it is having 24 IO pins. Okay, these are broadly classified into 3 ports: port A, port B, and port C. Here CWR decides whether the port is acting as output or it is acting as input. If port is input means we need to place 0. Sorry, we need to place it as 1. If it is output, we need to place it as 0. Okay, actually it is of CWR format is of 8 bits. So if you take 8 bits, 1, 0, 0, 0, 0, 0, 0 and 0. So if you take this is 4 bits as 8 and this is as 0, ATH, that ATH we have moved to the AL. Means we are telling that all the ports in the 8255 are acting as the output ports. Why? Because the output ports are giving us the inputs to the 8086. That's why we are placing the ATH. Means all the ports are declared as output ports here. Okay. And next we will write the logic. Actually it is move AL comma 88H. I am taking the 88 sequence and I am moving this 88 into the AL. And next write down move CX comma 1000. Why we need to write the 1000? I already said now. So for 5 rotations we require the 1000 steps. So we need to place the count value 1000 in the counter. And next we need to out it as this AL we need to send to the port A. In 8255 we are using the port A as output port here. So that's why I am sending the AL into the port A. Okay, and this is about, and next we need to call the delay here. Okay, why? Because winding to winding we require some delay. So call some delay. Let it be, if in the question they mention 10 milliseconds, after every 10 milliseconds the winding is going to on. And next we need to perform the clockwise now. For clockwise, which instruction we need to use? ROL. So rotate left AL comma 01 means in AL it is having 88. We need to rotate left for 1 time. So for how many times we need to rotate it? For 1000 times now. So for this we need to decrement this count, decrement CX. Okay, it is going to decrement. Next it is count value is 999. Next 999. It is going to decrement the count value. And next jump if not equal to 0. JNZ means jump if not equal to 0, back 1. If it is not equal to 0, again this loop is going to repeat. Okay, this is the actual module for the clockwise. Next we need to write for the anti-clockwise. So I am erasing this part due to space constraints. I am continuing from here only. For space constraints I will write from here. So again write the entire module as it is, just replace with ROR, just enough. Okay, move AL comma 88H, move CX comma 1000 and back to out port A comma AL and call delay for winding to winding. And here for anti-clockwise we need to write ROR AL comma 01, decrement CX. If it is not 0, jump if not equal to 0, back to. This is the module for anti-clockwise. And after whenever it is 0, it reaches to 0 count value, we need to end this segment. So code ends means end segment. Now we are ending the code segment and we need to end this start also. End start. This is the ALP for the stepper motor. I hope all of you understand. Thank you so much. Thanks for watching.